And in this section, we look at kind of the end of the identities. And these identities, I give you all the identities in here too. These identities show up, at least the sine and cosine, they'll show up a little bit more in calculus than the sum difference ones do. I can think of times when they show up. So I'm going to show you how to derive these, because the derivation of these things turns out to be super easy. And the more of these things you learn how to derive, the better off that helps you in higher math, if you can reason out how these put together. So basically, the first identity is this: the sine of 2 theta is 2 sine theta cosine theta. Okay. Here's how you derive this. It's real simple. What you do is you write the sine of 2 theta. You just write it as sine of theta plus theta. Okay, you got to remember to do this though. Well, I just taught you the sine sum identity. So that's exactly what we're going to do, is just pull out that sum identity from the last section. And it goes like this. You just go like this. You go sine of first, cosine of second, same sign. Then backwards, you do cosine of first, sine of second. Okay, that is the sine sum identity that we worked with in the last section earlier in class today. Well, see, they're the same. These are like terms. So there's sine, cosine, so sine, cosine. Therefore, there's 2 of those. That's a super easy derivation. That's how you get that, that particular identity. Okay, so if you ever forget it, that's how you get it. Of course, you got to remember the sine sum identity to do that. Okay. Right, the next one that we're going to derive is this one. And generally, textbooks always pretty well give 3 forms of the cosine 2 theta identity. And I'll give you those 3 forms, but it's nice to know where they come from. So the derivation on this is also very simple. So here's what you do. You go cosine 2 theta, and then this one's equal to cosine of, you just write it as cosine of theta plus theta. So I just build it the same way I do the last one. And then we do the cosine sum identity, which is the one that goes cosine, cosine, sine, sine, different sine. So it goes like this. You go cosine of the first angle times cosine of second angle, and then you go sine of the first angle, sine of the second angle, and then different sine. So again, that's the cosine identity we just learned. Well, look what happens. It pops right out of it. You get cosine squared theta minus sine squared theta. Okay, this is the way I a lot of times remember a lot of these identities. I know how to derive these things. Okay, so with a few basic ideas. So now what I'm going to do is show you 2 other forms. So the first thing to do is, let's just write down the identity that we just got. So we have cosine 2 theta equals cosine squared theta minus sine squared theta, like this. Okay, so the identity that you know, remember the Pythagorean identity, sine squared plus cosine squared theta equals 1. And you don't have to write this down because you can do this in your head. So for instance, the first thing I'm going to do on this is I'm just going to move the sign over here, and I would end up getting cosine squared theta equals 1 minus sine squared theta. You don't need to write that down because you process it in your head anyway. So what I'm going to do is replace the cosine squared with this, and then I get a different form of the identity. So I get 1 minus sine squared theta. I bring down the other sine squared theta, so I end up getting 1 minus 2 sine squared theta, like that. So that's that second form of the identity. Okay, and all you're doing is just replacing, using that Pythagorean identity to get that. The second thing you can do is you can go like this. So if you have the cosine of 2 theta, again, I'm going to start with cosine theta minus sine squared theta. Okay, well, I can also rearrange this identity this way. If I have sine squared theta plus cosine squared theta equals 1, what I can do is I can move the cosine to the other side to get sine squared theta equals 1 minus cosine squared theta. Okay, so I'm going to do this. I'm going to replace sine squared with what it's equal to, and then I end up getting another form of that identity. So we get cosine squared theta minus parentheses 1 minus cosine squared theta, and then just do a little basic algebra, and then you get the third form of this identity that goes like this. So you would get cosine squared theta minus 1 plus cosine squared theta, distribute the negative through. You have like terms. Cosine plus cosine is 2 cosine squared theta minus 1. So that gives you that third form like that. Okay? So basically what I tend to do is I tend to remember cosine squared theta minus sine squared theta. I don't remember the other two, but I just derive them real quickly. Okay? I will give you those three forms of the identity, and sometimes one of the forms is makes the problem a little bit easier. Okay? And then this next one is a tangent. Sometimes I don't remember how to derive this. I'll try and see if I remember how to do this one. So what I'm going to do with this one, the derivation of this one, let's try this approach. Let me see if I remember how to do this. So we could do the tangent is the sine over the cosine of 2 theta like that. So we could start it that way. And then I think probably what we need to do is use the identities that we just kind of developed. So if you look at the top of the page, notice that the sine of 2 theta is 2 sine theta cosine theta. So I'm going to try this approach. I'm going to write this as 2 sine theta cosine theta, like that. Okay, then I think I'm going to use for the cosine, I'm going to use this middle form. I'm going to use like 1 minus 2 sine squared theta like this. Hopefully I'll figure out how to do this right. I think it works out in kind of a certain way if you do this. I'll have to play with this a little bit. This is my thought. I want to end up with a 2 tangent. Well, it would be nice if I had sine theta over cosine theta. So I think what happens is if you multiply the numerator by 1 over cosine squared theta, it might work. I don't know. I always forget how to do this one. So I'm going to try this and just see if it leads me anywhere. If not, I'm not going to worry too much about it. Sometimes I have to play with this one a little bit, and it's not as straightforward. So let's see if this even works or not. It might. Let's see. I have a feeling that it's not going to work. Okay, so anyway, let's try it. Let's see. We would have this. So we'd have 2 sine theta cosine theta. And then I'm going to divide that by cosine squared theta. So I'm going to just put cosine theta like that. And then the denominator, I wonder if I would have been better. Let me just go with it. Go with the flow and see what happens. So I'm going to go 1 over cosine squared theta, and then minus, and then I have sine squared theta over cosine squared theta like that. Let me see what comes out of this. I think it's not going to work. I was afraid of that. Okay, that crosses out. Okay, that would be 2 tangent theta. Okay, and that's what I'm looking for, so I got that. However, that's kind of screwing up there, so that does not make any sense. I don't think I did anything wrong. Well, let's see, that would have a 2 in it too. I'm sure it'll work out of here somehow. So let's see, I wonder if I should have done a different idea. Let's do this. Let's do this. Now I see it. I always tell you, I never see this thing with them immediately. So here's what I should have done, I should have done this. Okay, I should have done this instead. I should have done cosine squared theta minus sine squared theta. Then it works beautifully, okay? So it goes like this. All right, so the denominator, what I should have done is I should have done cosine squared theta minus sine squared theta. and then I'm just dividing both of those things by cosine squared theta. Now it works beautifully, because see, that gives a 1, and then this thing, sine over cosine, is tangent squared theta. So that's it. Okay, I knew I'd figure it out. Okay, just kind of a matter of playing around with it a little bit until that form of the identity works out. You don't have to know the derivations, but I do think it's kind of helpful to at least know how to get those first two, and then how to get all three forms of that cosine 2 theta identity. But again, I'll give these things to you, okay? Okay, and the more of these you memorize for calculus, the better. It kind of depends. Sometimes teachers will give some of those identities. Most of them you want to know going into calculus, though. All right, so that's the derivation of those. I want to go to the next page and work out a few things on these, just to kind of get the familiarity with the identities. Mainly what we're going to do with these identities is use them to prove identities, and just do one exercise to just kind of get comfortable with the identity. So on this particular problem, you're given the sine is -3/5. You're given that you're in quadrant 3. So we're going to figure out the sine, cosine, and tangent of 2x on each one of these things. So let's start by doing just the sine of 2x. Now, what I would recommend that you do on this, again, is you have sine of x is given in this problem as -3/5. Since you're in quadrant 3, that's going to mean that x is negative, y is also negative, and r is positive. Okay, then all this information you should be able to do in your head. The sine is y over r. You want to, of course, know your definitions. So y is -3. R is 5. Do you know in your head what x is? I hope so. 4. That's a Pythagorean triple. If you don't know that, then you can go to your Pythagorean theorem. So we're just going to work out these things. The first thing we're going to do is the sine of 2x. So just pull up your identity. You can look these up until you get them memorized. So basically what we would have here is 2 sine theta cosine theta. So we just write down that identity is 2 sine theta, or 2 sine x, cosine x, like that. Okay, and see, we know all these things. So we know the sine is y over r. So that's -3/5, and that's what I gave you anyway. And then the cosine of x is x over r. So that would be -4/5. So you just work out that arithmetic, and that would give you the solution to the problem. So you can multiply straight across. That looks like that would be an answer of 24/25. So all this is it's an exercise in learning your identities. Okay, you mostly use these identities for derivations and proofs and equations and stuff like that. All right, the second one, let's do the cosine of 2x. Now let me ask you a question on this. You can use any three of these forms you want to. This is the way I would look at it. I gave you what the sine is. So to me, it would be logical to just use this one. Don't you think? Because it's only got a sine in it anyway. It's your call. You'll get the same answer regardless of which one you do. But to me, it's a little less work to use 1 minus 2 sine squared x, just because I gave you what the sine is, see? So then all you got to do is work out 1 minus 2 times -3/5 squared. That's why I'm using that identity, because I gave you the sine. That's your call. You can do whatever you want to. Okay, so this would then give me 1 minus 2. Square the fraction, you're going to get 9/25. And then this would be 1 minus 18/25. So you just get a common denominator. So from here we would have 25/25 minus 18/25. And that would give 7/25. And notice on that, I didn't even basically have to even worry about what quadrant I'm in. It didn't make any difference, so we get that. Okay? All right? So the next one is the tangent. Now, you got a couple of ways you can do this. You can use the identity if you want to. Okay? What's another way you could do this problem without doing this tangent double angle identity. There is another way. What do you know about tangent? It's sine over cosine, right? So it would be just as easy on this problem to do the problem this way. I know, like on my math lab, I put a problem like this on the homework on here, and you can do it this way, okay? You don't have to take the time to do that other identity, so you just do sine of 2x that we got the answer on, and then cosine of 2x. So that would be 24 over 25 over 7 over 25. The 25s cancel out, so you get 24 over 27. If you used that tangent double angle identity, you'd get the same answer, but it's not worth it. Okay, all right, you guys with me? Okay, okay. All right, let's see. The next thing I'm going to do is just do a proof. That part B did not come out correct. Is this on your handout like this? That B, is it like that or something else? Okay, so we can't prove that. So we're just going to leave that alone. I must have finished typing it in or something. Okay, I just got distracted or something. I had, like in my house, 3 power failures over the weekend. Anybody else have a power failure? It's just super windy out where I live. I live in Roxborough, which is in Southwest, and it's just so windy in my backyard. Blows power lines down all the time out there. So I may have kind of got distracted by that or something. So let's just do this one proof. And this will go like this. Let's see, this one I've got. And the thing on these proofs is, I have a lot of experience doing these, so I usually kind of see simple ways to do these sometimes, but sometimes you're going to go in circle on these. Actually, it turns out that the easiest way, I think, to do this problem is to actually work with the right side and change it into the left side. Okay, and it is good that you see some of the tricks that I know. Now, see, what we're learning about is double angle identity. So here's something that you can do. You can write that 4 theta as double a 2 theta. Okay, and if you don't see this, I think this one could be a little tricky to prove the other way. I'd have to think about it though. So here's the idea, is I'm going to use this identity right here. And the reason I know to do that is because, look, I'm trying to prove it's equal to cosine squared of something minus sine squared of something. Okay, that's what I do. Well, here's how you do it. Like one more step and you're pretty well done when you get right down to it. So it turns out that when you do the double angle identity for cosine, what you do is you do the cosine squared of that angle. But that angle is not theta, that angle is 2 theta. Okay, like that. Okay, and then you do minus sine squared of that angle. Look at that, you're already proved. Okay, now what I think is sort of difficult for students to see sometimes is, according to this identity, you're always just doing cosine squared of the angle minus sine squared of the angle. The angle started 4 theta, but I wrote it as 2 times 2 theta. That's why it turns out that way. Does that make any sense? Okay, that's the easy way to prove that one. Okay, 2 steps and you're done. Okay, and I think sometimes students struggle to see how I wrote that first step and how it relates. That's the idea. Okay, all right, I'm going to show you one other thing. You don't need to write this down, but if you had something like, say you had something like cosine of 8 theta, then you would go like this. You would just do cosine of double 4 theta, right? Then what would the answer be? Then it would be cosine squared of what? 4 theta minus sine squared of 4 theta, like that. Okay, that's how that goes. Okay, that's the simplest way to prove that one. So I just forget about B. I don't even know what the rest of that is. If I knew the rest of it, we could prove it. Okay, so the next thing I want to show you is the half angle identities. And again, I'm giving you all these identities, so you don't have to worry about memorizing all these things. These identities show up in Calc 2 a lot. So probably when you get to Calc 2, you'll have to kind of refresh your memory on these, because you actually will use these quite a bit in Calc 2 in integrals. So basically, what I want to suggest, we're going to use these 2 identities. Now, you want to make a note of this. The tangent of alpha over 2 has 3 forms, but this one is the best by far. So there's hardly any time when I even use those other two. Okay, and that's a good thing to write down when you're doing your homework. If you're doing a tangent half-angle identity, don't mess with the other two. You can, but it'll make the problem way more difficult. This is the easy way to use it. That's the best identity. So what we're doing with a half-angle identity is we're working with half of an angle. So it turns out that we can find exact values for other angles that don't fall directly on the unit circle with your special angles. So it turns out that this is half of 45. So in other words, the sine of 22.5 could be written as the sine of 45 degrees over 2. Okay, so and 45 is a special angle, so we can use this identity to do this. And I'll talk about the plus or minus, how that works. So let's just refer to that identity on the top there. So when you set this up, we would have plus or minus, and then you would do exactly what that identity tells you to do. You would say 1 minus cosine. You don't say 22.5, you say 45. Okay, a lot of times I see students do that wrong all the time. Well, you know the cosine of 45, and then you just do that over 2 like that. That's the setup of that identity, and in a little bit we're going to crunch this out, but I just want to get you comfortable with setting up. Now, what's the deal with the plus or minus? Well, first of all, 22.5 is in quadrant 1. So what's the answer to the sine of any quadrant 1 angle? Positive or negative? Positive. So that means the answer is positive because you're in quadrant 1. Okay, so basically you would just set it up like that. So you always have to figure out what quadrant the angle's in to determine whether you have a negative or positive answer. That's the idea. Okay. Okay, so the next one, we'll set this up kind of like this. And again, if they have a 0.5 in it, you probably want to just double the angle to see what it is. Okay, so I'm going to take 157.5 and double that angle to figure out what angle we're taking half of. What in the world did I do? I divided. Okay, so I double the angle, so that's 315. 315 is on the unit circle, right? So I'm giving you something that's going to fall on the unit circle in some way. So you would want to write this as cosine of 315 degrees over 2, like that, okay? So the setup would go like this. We would say cosine 315 degrees over 2, and then look at the cosine identity that's, on the top of your page there, and just do what it tells you to do. Okay, so we'd have plus minus, and then now it's 1 plus cosine of 315 degrees over 2. Okay, now we just got to figure out, is it plus or minus? Well, we're in quadrant 2, 157.5 is quadrant 2. So what's the cosine in quadrant 2, negative or positive? It's negative, okay? So that means this one is going to have a negative answer. So that's one thing you have to pay attention to on these problems when you do that, okay? Okay, so go ahead. I want you guys to just set these up, just like I did. Figure out whether it's positive or negative. Look and see which identity applies and just see that you can put these together. Sometimes students, when they're learning these things, don't put them together right and don't get the sign right. And again, just double the angle to figure out what you're taking half of. If there's a 0.5 in the angle, there's a good chance it has something to do with a half angle identity. But I try to make these up so they'll work out okay. And then on the next page, we'll start kind of crunching these things out a little bit here. The sine identity's got the minus and the cosine's got the positive. I remember that because I teach Calc 2 a lot. And they show up a lot. So the first one, is it positive or negative? Since after all, let's say you're doing a quadrant 2 angle, cosine, so what should you get? Should get a negative, right? Because that first one's negative because the cosine's negative in quadrant 2. And you'd set it up like this. You'd have the negative, and then it's just, I doubled that on my calculator. So I got 225 over 2, so it would go negative square root of 1 plus 225 over 2. That's how that sets up. The second one, you double it, you get 315, just like the last problem. Is this negative or positive? It's quadrant 2, what's the sign? That's positive. The sign is positive in quadrants 1 and 2, so that one you should have a positive answer on. Then the setup would be like this. You have the positive radical 1 minus cosine 315 over 2. So that's how you set up and use the half angle identity, okay? All right, any questions about the setup of that? Okay, and figuring the sign out. Be sure that you always figure that sign out at the beginning of the problem. And these problems are designed so doubling the angle puts you somewhere around the unit circle, okay? All right, you can't do that with just any old angle. So let's crunch a few of these out, and we're gonna crunch these out and get the exact answer. The answers on these kind of look strange when you do this because you have a radical under a radical, but that's okay. Okay, so with this one, what you can do on this one is you can either leave it in radians or you can convert to degrees. Generally, when I'm teaching this, I just always convert these things to degrees. And you can look at the unit circle. This one is 5 pi over 6 is 150 degrees anyway, okay? So that's really the sine of 150 degrees. So if you double that angle, you would get the sine of 300 over 2. Okay, so that's how that would get put together. And then if you look at the identity, let me ask you this question. I'm losing my voice. Are you going to have positive or negative answer for sine 150? You're going to have positive, okay? All right, so we're in quadrant 2. Don't worry about the 300. Worry about the original problem. So what we would do is it would go like this. We would have positive answer, and then just look at the identity. So we would have 1 minus cosine of 300 degrees all over 2. So that's the setup like I showed you. Then what we need to do, you can look at the unit circle I have displayed up here. So the cosine of 300 degrees is 1/2. Okay, so this one would get put together like this then. So what you would have is the square root of 1 minus 1/2 all over 2. All right. Now there's more than one way to simplify. This is the way I would do this. I want to get rid of that 2. So I just go under the radical and multiply both the top and bottom by 2. You can go under the radical and get rid of fractions like that. Okay, and then if you do that, it's basically going to go like this. I'll just kind of move this up here. So I would end up having square root, do a distributive property, 2 times 1 is 2. And then when you multiply that out, that would be a 1. And then the denominator is a 4 like that. Then you can split it up. So it looks like you would have square root of 1 over 4. So that would be 1/2. Okay, isn't there an easier way to do this problem without even looking at this identity? Look at the unit circle. Sine of 150 is 1/2. Okay. Worked. Okay, I just wanted to show you how that works. I think the next two problems, we have no choice but to use the half angle identity. But that one gives the answer we expect to get anyway, say. Okay, so that's how we put that together. Okay, the next one. So I think we already did this earlier, and I think we got 315. So if you double the angle, you get 315. So the way we're going to write this one in the identity is like this. I think we already set this up on the previous page. So really, we just write this as the cosine of 315 degrees divided by 2. Okay? So again, we're in quadrant 2. The original angle's in quadrant 2, and the cosine is negative in quadrant 2. So when you begin to put this together, you want to follow the cosine identity that I'm highlighting in green and just do what it tells you to do. So it would be negative square root 1 plus cosine of 315 all over 2. Okay, like that. And then what we'll do is just kind of look up 315, look up the cosine. So the cosine of 315 is square root of 2 over 2. So it goes together like this then. So you would have negative square root of 1 plus square root of 2 over 2 all over 2 like that. Okay? And then the approach to doing this problem is, well, you got this 2 that has a complex fraction, so go under the radical, same way I did on the last problem, and just multiply by 2 over 2. Okay? And when you do that, you'll end up getting negative square root, do a distributive property, 2 times 1 is 2. The next part will cancel the 2's out, leaving you another square root, which is okay. Then you get square root of 4 like that. And it's okay to have a square root under a square root. So basically what you do on this is just split it up. You can do the square root of the top and you can do the square root of the bottom separately. Now you can do this in your head. I don't care if you just write the answer in your head. So the final answer we write is negative square root of 2 plus root 2 all over 2. It's a weird looking answer, but that's what you get. You just don't want to have a square root in the denominator, but you can have a root under a root. Okay? When you start learning about series and stuff in Calc 2 and stuff, you can learn about radicals under radicals infinitely and stuff in kind of a series format, so you do that. Okay, does the algebra make sense on that okay to everybody? Okay? Sometimes the algebra on some of these things is what students have some background issues from time to time. Okay, now the tangent. Okay, which identity did I say you always use on the tangent alpha over 2? Were you listening? This one. Okay, don't go with the other 2 places. I noticed on one of the problems on my math lab, they did the problem with that first one, and there's no need to do that. It's just way too complicated. All right, you'll always do these problems 10 times easier if you just use the last identity. So again, this one goes like this. We would go double the angle is 45. So what you'd want to do is just write this as tangent of 45 over 2 and apply that last identity. Okay, so we go like that and just do exactly what that identity tells you to do. So the identity says 1 minus cosine, not of the 22.5. I mean, students make that mistake a lot. You don't know what the cosine of 22.5 is without using your calculator. So that's going to be cosine 45, then over sine of 45 like this. The benefit of doing the problem this way is you won't have to worry about rationalizing a denominator with a conjugate the way you would if you use the other one. So it's easier. You still have to rationalize, but you don't have to, at least have to worry about a conjugate. Okay, so hopefully you guys have sine and cosine of 45 memorized, do you? I hope, root 2 over 2, okay? All right, so what you get is you get 1 minus root 2 over 2 all over root 2 over 2. And see, that's not too bad to simplify. So the way you would do this is multiply the top by 2 and the bottom by 2. I usually just show to do this in 2 steps. Okay, and then what will happen is distribute, that'll give 2, and then when you multiply that, that takes out the 2's to give you 2 minus root 2. The bottom just gives you root 2. And now you do have to rationalize, but you only have to multiply by square root of 2. So it's easier than the other forms of the identity. So now multiply the top by square root of 2 and the bottom by square root of 2. Okay, and by doing that, we end up getting this. We get 2 root 2 minus square root of 4, and you can do some of this stuff in your head, all over square root of 4. So you would end up getting 2 root 2 minus 2 over 2. And then you can just split it up, see, okay, you can do it in your head, but you're really just doing 2 root 2 over 2 minus 2 over 2, and that would end up giving you an answer of square root of 2 minus 1, like that. So that's what the exact answer to the tangent of 22.5 is. So identities can be used to find more precise values of other angles, okay? The majority of angles you have to use technology on, and when you get to Calc 2, you'll start learning about series, so you start learning, well, what does the calculator do behind the scenes when it's doing something like the tangent of 3.5? It's doing a series, an infinite series, and you'll kind of learn about, well, how do we get all those infinite decimals of pi? Well, it's a series. So it kind of gets interesting towards the end of Calc 2 when you start learning about series. That's a very interesting topic. Probably one of the hardest topics in Calc 2, though, for a lot of students. Okay, you guys with me on what I did there? Okay, so half angle identity, you don't have to worry about memorizing any of these identities. You just got to know how to utilize these things and put these together. Okay, so the next thing I'm going to do is I want to go ahead and get one more problem with half angle identities. Then we're going to do some trig equations. And I noticed that this semester that the department was saying, you don't have to teach trig equations. And I'm telling you, when you get to calculus, you have to know how to do trig equations. So I'm putting together kind of an overall thing that the absolute most important things that show up in trig equations, because they will show up in Calc 1 from time to time. So we need to go through some of these that are showing up, at least in this section, and I think you'll probably be okay. So with this one, we're going to do kind of use these identities, and we're going to just crunch out arithmetically sine, cosine, and tangent using the half angle identities. So this one is similar to what we were doing on previous problems. So we are in quadrant 2. So that means that x is negative in quadrant 2, y is positive, and we know that r is always positive. So I've given you a secant is equal to negative 3. You have to put that over 1 so that you can figure out 2 of the variables. So the secant is r over x. It's the reciprocal of the cosine. So that means you would have negative, let's see, r would be positive 3. It would have to be. It would be the x that would be the negative 1. Okay, because r is always positive, so don't fall for that. Be careful about that. And then what you'd have to do is do the Pythagorean Theorem. So you would have x squared plus y squared equals r squared. So that would give negative 1 squared plus y squared equals 3 squared. So I think this will give you square root of 8 again. So this is 1 plus y squared equals 9. That's y squared equals 8. And we'll skip a few steps on this. So you'd end up getting y equals 2 root 2. We worked with that before, and I think we did that same thing earlier today. So you would end up getting y is 2 root 2. So we've kind of done this idea several times in class today. You're given a trig function. That's enough information to figure out x, y, and r as long as I give you the quadrant that you're in. And what we're going to do is just kind of do each part of this then. So we're going to do the sine of x over 2. We don't have to know what that angle is. It doesn't matter. So we're in quadrant 2. And the thing is, now what you have to be kind of careful about on this is this then. This angle x would be something that's being doubled. And this is the trickiest part of this problem is this. I'm telling you that this angle right here is in quadrant 2. I'm not telling you what the angle we take in half is. Okay, so what happens is you're taking this angle and dividing it by 2. Well, it's okay. What happens if you take a half of a quadrant 2 angle? Then where are you? You're in quadrant 1, right? Okay. All right. Okay. No matter what the angle is in quadrant 2, if you take it in half, it puts you back in quadrant 1. So that means that the answer in this plus or minus is going to be positive. Okay. Don't pay attention to the quadrant 2. Remember, you're doing half of that angle. So you're in quadrant 1. So you'd end up having a positive, okay, and then the identity would go like this. It would be 1 minus cosine x over 2, like that, all right? So it would go like this then. When you put this together, you would have the cosine would be x over r. So notice that that x over r would be negative 1/3. It'd be the reciprocal of the secant, so you would have 1 minus negative 1/3 all over 2. So that's what you'd have to work out. So that would be the square root of 1 plus 1/3 all over 2. And again, I would get rid of the 3. Okay, just get rid of the 3, or you can get a common denominator, it doesn't matter. But to me, it's just as easy to do it this way. So go under the radical and multiply by 3. Okay, by doing that, I'll just kind of move this up here, you would end up getting the square root of 3 plus 1, because I'm doing a distributive property, and I'm canceling the 3's out, and then you would have over 6. So that would end up giving the square root of 4 over the square root of 6. Okay, that would be 2 over root 6, and then you would want to just rationalize the denominator, okay, which you can do in your head. So multiply by root 6 over root 6. The answer to that problem would be 2 root 6 over 6. Then you can reduce the 1/6 down to 1/3. So you should get, as a final answer on this, you should get square root of 6 over 3 should be what you get on that problem then. Okay, like that. So again, I'm applying the identity, and you figure out the cosine. Just, you could actually, you could even bypass all this stuff because the secant, the cosine's a reciprocal of the secant anyway, so it's negative 1/3. So that's how you would get the first part of that problem. Okay, the second part we'll do is the cosine of x over 2. So we just do kind of the same thing. I'm going to erase what I have on the Pythagorean Theorem. Don't really need that anymore. So we're going to do kind of the same thing on this. So just the cosine of x over 2 is, and remember, we did half of a quadrant 2 angle to get quadrant 1. So it will be positive square root. This time it's 1 plus cosine x over 2. So it's almost the same thing, except you have that sign difference. So this is going to be equal to square root of 1 plus the cosine. The cosine is negative 1/3 over 2. The mathematics is all the same. You would just go through under the radical, multiply by 3 over 3 to get rid of the fraction. Okay, so that would end up giving 3 times 1 is 3. Cross out the 3's to get minus 1. Still over 6. So this time it looks like you would end up with square root of 2 over square root of 6, like that. And then you can rationalize the denominator. Okay, so that would end up giving square root of 12 over 6 when you do that. And then you'd want to reduce that, so you could break down the 12 could be broken down into 4 times 3, like that, just simplifying the radical. So that would be 2 root 3 over 6. And then you could reduce the 2/6 to 1/3. So it looks like you would get root 3 over 3 for your answer on that one. There's a bunch of arithmetic on these problems, primarily with radicals and stuff. Okay. All right, and then I'm going to do this last one here. So again, the tangent, be sure that you're always just using that last form of the identity. I can't think of situations where it's beneficial to use the other two. So if I do tangent of x over 2, then I just do 1 minus cosine of x over sine of x, okay, like this, okay? So the cosine of x is x over r, so that would be 1 minus negative 1/3. The sine of x would be y over r, so that would be 2 root 2 over 3, like that. So you got to simplify that expression then when you do that, okay? So this is going to give 1 plus 1/3 over 2 root 2 over 3. And it's exactly the same kind of procedure on this. Once you get everything put together, you can multiply the top by 3 and the bottom by 3 to get rid of the fraction. So we would end up having here 3 times 1 would be 3. A third of 3 is 1. And then the bottom, you just have 2 root 3 like that. Okay. So that looks like that would be 4 over 2 root 3. 4 over 2 is 2, so it's 2 over root 3. And then you can rationalize the denominator. Okay. A lot of arithmetic. Okay, so it looks like the answer on this would be 2 root 3 over 3. Okay, you're going to end up with a bunch of complex fractions when you're dealing with these problems. Yes. Well, let's see, the sine, which part are you talking about? Well, I had a 2 root 2, right? I might need you to point so I can see. So I got the identity okay. That's good. Y was, let's see, the sine's Y over R, so that looks good. Okay, so what am I missing here?
And then you multiply by 3. Now the denominator with 3 is crossed out.
So you'd be left with 2 root 2.
Yeah, you have 2 root 3.
Ah, okay. That's the hardest kind of problem for me to see. Okay, yeah, duh. Okay. Sorry about that. So it just magically changed from 2 to 3. Okay, I didn't mean that. Okay, well, I just changed the problem. Did I just do the same thing? I just erased it and did the same thing. Okay. So I got 2 root 2. Okay, so again, I got 4 over 2 root 2. So that's 2 over root 2. So rationalizing would give you 2 root 2 over 2, so you get root 2. How's that? Is that better? Okay, sorry about that. Okay, so that's a good stopping point. We'll just wrap up the trig equations next time. Most of the trig equation stuff is interpretation of the unit circle again. So, but I do want to kind of get you through how to do several varieties of trig equations then too, okay?